Hello guys, I hope you all are doing good. I am Vaishali Kikan and we are discussing the optical communication. Today in this video, we are going to see the difference between the PIN photodiode and the Avalanche photodiode. So let's start without wasting any time. We have already studied about both of them and we know their basic structure. In the PIN photodiode, we have the three layers. You can see we have the P plus region, then we have the N region, and then we have the intermediate region. So now this three regions overall forms the PIN photodiode, which is reverse biased. So now here if I supply the biasing, it is reversed bias. This is the basic structure of the PIN photodiode. So you can see here we have three layers, one very small layer for the P plus region, one very small region for N plus region, and a very large I region. So now here we will be having the four layers. In the four layers we have the N plus layer, right? Then we have the P layer, then we have the pi layer, and here we have the P plus layer. So now P plus pi, P, N plus layers are there. Again it is reverse biased, and this is the structure of my Avalanche photodiode. So now here you can see P plus I, N plus P, pi, P plus region. So here for the formation of the Avalanche photodiode, we have to use sophisticated techniques, and this is the reason its production is complex and it is costlier, right? This is the first difference between the two. Now coming to the gain. As I already told you, in this PIN photodiode we had various advantages like the high efficiency, low noise, higher bandwidth, but there is this problem that we are not getting any internal gain. So internal gain is not provided from any of its part, and here we are getting the gain which is less than 1. So output current would be less than the input current, but here in this case we have the gain region. So here with the absorption region we have the gain region as well. So this is the gain region, right, near the N plus P depletion region, and here we have the absorption region where the light absorbs. So here we are having the internal mechanism by which we are providing the gain. So gain is greater than 1 in this case, right, because we are having the carrier multiplication due to the impact ionization. The carriers will move to the gain region, and here they are going to multiply with the help of impact ionization, and their multiplication is happening the same way the avalanche is happening. So in the avalanche the snowball is coming down the hill of the mountain and it is increasing in size. So from 1 electron we are generating 2 electron, from 2 4, from 4 to 8, from 8 to 16. So this is how the avalanche multiplication is happening, and we will be having very high gain in this case. Now external amplification is required because the internal amplification is 0. Here because we already had the internal amplification, there is no need for having an extra circuit of external amplification. Now here it is going to give me the faster response. So the response time is less, right? It is a faster device. This is a slower device because the response time is high in this case. So if I want to generate the response in a faster manner, I will switch to PIN diode. Now the noise are generated due to the photon noise, Johnson noise, short noise generation, and the recombination noise as well. So all of these noise, if I add up, these are comparatively lower than the noise which are there in the Avalanche photodetector. These are high noise. So now here we have short noise, thermal noise, and the avalanche noise, over which the avalanche noise is the biggest noise because here we are getting the noise with the gain. So noise is also amplified. For that reason I will be having high degraded performance by the Avalanche photodetector if it is present in the noisy environment. Noise is also going to get multiplied. So here the sensitivity is less. The sensitivity of the Avalanche photodetector will be very high. So here we don't require a very high reverse breakdown voltage. This VB, the voltage that is required for its operation, is a very less voltage, but here the reverse bias voltage VB that is required for its Optimal operation would be very high near to the breakdown voltage, and near to the breakdown only I am going to get a very high voltage in the gain region of the order 10 raised to power 5. This is how the gain is happening. This is how the impact ionization happen and the carrier multiplication happens. So a very high voltage nearly around the breakdown voltage is required. The output current would be high because gain would be there. The output current is less because the gain is not there. So here it does not depend, PIN photodiode does not depend upon the temperature fluctuation. It is having higher stability towards the temperature fluctuation. But I have already talked about the temperature dependence of the avalanche gain in the previous video. I hope all of you have seen that video. So there I told you how badly the avalanche photodetector is affected with the temperature fluctuations. So current gain changes significantly on the temperature fluctuations. So I hope you understood the basic difference between the PIN photodiode and the avalanche photodiode. In the next video, we are going to talk about the noise associated with the photodetectors. I hope you understood each one of these things in detail. If you have any doubt, you will put the doubt in the comment and I will be trying to resolve your doubt as soon as possible. I hope you like this session. If you like it, please push the like button, subscribe to the channel, share it with your friends and give me your feedback. Thank you so much.